Hi YouTube. Today I'll be presenting a time series analysis on Tesla's stock prices. This study was conducted by myself, Ross Fu, and my partner, Emil Ramos. The Tesla stocks data was originally sourced from Yahoo Finance, and it represents Tesla stock prices from 2010 to 2020. Tesla stock prices have recently been on the rise. There's been a huge increase in Tesla stock prices recently. You can see the original data set on the bottom left. Here you can notice non-stationary behavior. You can see that the mean is not constant with time, the variance is not constant with time, and the ACFs show slowly dampening behavior, which is a strong indication of non-stationarity. The spectral density has a peak at 0, which indicates wandering behavior. There's a lack of any other peaks, which would suggest other cyclic behaviors. For this study, we've decided to truncate the dataset. We've removed the first 700 time points of the dataset. The first 700 time points contained data that were not consistent with the rest of the dataset, and so we chose to focus on the most recent data. The ACFs and spectral densities appear to behave largely the same. Because we've determined that this data is non-stationary, we will take the first difference of the data and examine if we need further differencing. The first difference data appears normal and white noise-like and non-stationary. So we could proceed with this, but we're also actually interested in the second difference data, and we'll talk more about that. So with the first difference data, an investigation into the AIC scores determined that a 413 would be appropriate to model this data set. So we've defined a 413 model on the bottom of this slide, and you can see the forecasting behavior on the top right. We've chosen to predict 30 time points for our predictions, as this seems to be appropriate for stock trading. Here we have an ASE score of 20,000. Now, we made a model using the second difference data because when you make a REMA 2 term into your model, your forecasts will predict the trend to continue. Now, this is forecasting behavior that we were interested in, and so we investigated this approach, and so you can see the definition for this ARIMA 2.2 model at the bottom. The forecasting behavior was able to follow the trend, the recent increase, if you will, in the Tesla stock prices. It did a good job of following this unexpected increase. Notice that the ASE score here is 13,000, an improvement. We also created a VAR model to make use of other explanatory variables, which may help us answer our predictions. So a VAR model can combine multiple explanatory variables and then determine an appropriate p-value to model them with. Here we've determined that a P5 VAR model would be appropriate for our data set. You can see that the forecast for this model stays flat. Stays flat and expects the model to return to the mean. However, the ASE score is quite low with a value of 3,150, our best, most accurate model yet. The fan charts here give you a look at the confidence intervals for these VAR predictions. We also created a neural network model for this data set. For this model, the neural network has 5 hidden nodes and used 20 repetitions. The difference, we defined another difference factor within this model, and that improved our ASE score to 1600. You can see that the forecasting behavior on the bottom right includes some movement. Now, we chose to ensemble the accuracy of the neural network model, which had our lowest ASE score, and we decided to ensemble that with the ARIMA 2.2 model, because the ARIMA 2.2 model was able to follow the trend. And so you can see the blue forecasting region here is actually very accurate when compared to the original data. The ASE score here is 4,000, but the forecasting behavior looks promising. So, once we compare the results of all of our models, it appears that our neural network models performed the best, the most accurately, followed closely by our VAR model and the ensemble model. Thanks for watching.